Greetings, I'm Dev the developer.
And I'm Glitch. I'm here to ensure your data is as sharp as my wit, or at least sharper than Dev's fashion sense.
Last time we learned to pass behavior as a value using lambdas. Today we pull back the curtain on how foreach actually works, then use that to filter and transform collections without writing a single manual loop. Glitch. You've written foreach loops over arrays and over lists. Those are completely different types. Why does foreach work on both of them?
I assumed it was just the will of the compiler, like how some people just know how to fold a fitted sheet. It's either magic or a very elaborate conspiracy.
It's a contract, an interface. Both arrays and lists implement something called IEnumerable of T. Any type that wears that interface can be used in a foreach loop. That's the whole rule.
So IEnumerable is the one ring that binds them all, foreach is the bouncer, and as long as you're on the list, you're in. Doesn't matter if you're an array or a list.
Exactly. And LINQ, LINQ, is a set of methods that live on that same interface. Because they take lambdas, they will let you filter and transform any collection without writing a single loop by hand. So let's get some data on screen. We're working with a song record today. It has 5 fields: ID, title, artist, genre, and year. Glitch, set up the list and the record.
Song record check, song list check, and 3 loops that look different but output the same thing. It's like the Matrix, different interfaces, same reality. There is no loop.
Three lines, same numbers. The array, the list, and the LINQ result all iterate the same way because they all implement IEnumerable of T. Foreach doesn't care which one it gets.
Unified collections, it's beautiful. I could write one method to handle them all and then take an early lunch. Efficiency is my middle name. Well, actually it's a string of random hex characters, but you get the point.
Exactly right. And that's why LINQ methods return IEnumerable also. Every method in the chain stays compatible with every other one. But before we get into the methods, there is something important about how LINQ actually runs.
Execution, is this going to be a judgment day situation where the code decides it's had enough and just waits?
That's actually a decent analogy. Let's find out. I want you to write a where call, but make the lambda print something before returning. That way we can see when the lambda actually runs.
Query is drafted, then I add Africa. If LINQ is a tryhard that runs immediately, Africa is left behind. But if it's chill and waits for the loop.
Look at the output. Query defined adding Africa, then checking line start. Africa is in the results even though it was added after the query was written.
Life finds a way, and so does Africa. The lambda waited until the foreach bouncer called its name. It's like a recipe that only starts cooking when you sit down to eat.
That's deferred execution. LINQ is lazy. It builds a recipe and waits. The recipe runs when you iterate the result, or when you call the method that forces it.
Lazy, I call it strategically patient. Why do work now when you can do it later, or maybe not at all if nobody asks? LINQ is my spirit animal.
It's smart. Go ahead and close the console. Now, Africa is in the list now. Let's leave it there. The list has 5 songs from here on. When you want to force a query to run right now and hold its results, you call ToList.
ToList the I'm serious this time method. When do I actually need to stop being patient and just get the data?
3 situations. First, if you iterate the same query more than once, the lambda reruns every time. Second, if a method you're calling expects a list of t, an IEnumerable won't satisfy it. Third, index access. You can't use bracket notation on a raw IEnumerable.
So ToList is the freeze command. It takes a snapshot of the sequence and stores it in memory. No more lazy games.
Right. Let's also update the song list in the file to include Africa permanently. Glitch, lock in Africa as song 5.
Africa is officially canon now. 5 songs. Rock is dominating. It's like my personal hard drive, 90% classic rock, 10% sinister world domination plans. Where filters ToList freezes, I can use rocksongs.count and bracket access because it's a real list now. No more Schrodinger's data. It's either there or it's not.
For rock songs. Index 0 is Bohemian Rhapsody. That's what ToList gives you, a real concrete collection you can slice into with an index. Now, let's actually dig into where. It takes one argument, a lambda that returns a boolean. True means keep this element. False means drop it. The output is always fewer or equal elements, never more.
So where is the snap of the fingers? It decides who survives and who gets dusted based on a lambda. I think I'm going to like this.
Let's try a few. Same song list, filter by genre, by year, and by a string test on the title.
Genre, year, and title search. I'm using contains on the string because I'm looking for a specific keyword. It's like Sherlock Holmes, but with more semicolons and fewer hats.
For rock, 3 before 1980, 1 with hotel on the title. The predicate is whatever you need it to be. Any expression that evaluates to a boolean is valid.
With great power comes great responsibility and also a lot of ways to screw up my data. Can I chain these conditions together, like genre is rock and year is old?
Yes, 1 lambda. Any logic you want inside it. That's the whole point of accepting a func. You decide the rule. Where applies it? Now, select. This is a projection. Instead of deciding which elements survive, you decide what shape each element becomes.
Projection so I can turn a song into a string. It's like Pinocchio. I'm turning a real boy into a wooden data structure.
Every element goes through. The count in equals the count out. But the type can change completely. A song goes in and a string comes out.
First, select harvests just the title. Second one builds a custom label with string interpolation. Same 5 items, brand new identities. It's like a witness protection program for my data.
Five formatted strings, 1 per song. Same count, completely different shape. That's the difference. Where changes the count, select changes the type.
Got it. Where is for who, select is for what. But what if I want to do both? Can I filter and reshape at the same time?
You'd get a sequence of booleans, 5 songs in, 5 booleans out. All 5 regardless of the value. That's not filtering. If you mean keep only rock songs, that's where, not select.
Wait, I'm getting ahead of myself. I meant, can I pipe the results of where into select?
Good. Now, here's the payoff. Because every LINQ method returns an IEnumerable, you can change them directly. The result of where feeds straight into select, which feeds into ToList. One expression, multiple steps.
A pipeline like Inception, we're going deeper into the data until we reach the core. Each step refines the last.
Exactly. And the style convention is one method per line with a dot at the start of each line. It makes the chain readable. You can see every step at a glance.
From songs where genre is rock, select the title. As a list, it reads like a sentence. I'm basically a poet now, a testy data processing poet.
For rock titles, filter first, then transform. That ordering matters. If you select before where, you're projecting every element first, then filtering. You do more work for the same result. Filter early, logic is our job glitch.
Efficiency first, don't count your chickens before they filter through the rock genre. Got it.
Now, let's talk about getting a single element out of a sequence. Sometimes you don't want the whole filtered list. You want one thing, the first match.
Like finding the one in a list of candidates. Neo, is that you? I assume I just take index 0 from the results.
You could, or you could use first. It takes the same predicate as where, but instead of returning a sequence, it returns one element, the first one that matches. Try it. Find the first rock song.
First, with a predicate, it's direct, it's assertive. It's going to find the first rock song or die trying.
Bohemian Rhapsody, first rock song on the list. Now, here's the important question. What happens if nothing matches?
It returns an empty void, a null, a politely worded apology.
It throws. Invalid operation exception. Sequence contains no matching element. Let's prove it. Change the genre filter to jazz. We have no jazz songs in this list.
Jazz, in this list, I'm sensing a disturbance in the force. 3, 2, 1, crash.
There it is. Invalid operation exception. Sequence contains no matching element. That's first. It assumes a match exists. If you're not certain, use FirstOrDefault.
To throw or not to throw, that is the question. So first is for when you're 100% sure, and FirstOrDefault is the digital seatbelt.
Right. FirstOrDefault returns null if nothing matches instead of throwing. Then you can check for null before using the result. It's the safe version. You use first only when you can guarantee a match. Everything else gets FirstOrDefault.
Nullable song FirstOrDefault gives us a chance to handle the void without the fireworks. If it's null, we just print not found. Civilized.
Not found. No crash. That's FirstOrDefault. It handles the missing case gracefully instead of blowing up.
Check first, act later. It's a philosophy I could live by, if only people were this easy to filter.
Good. Now, two more that return a single boolean instead of a single element. Any and all.
Ah, the yes-no twins. Any is the optimist, all is the perfectionist. Let's see them in action.
They do. Any asks, does at least one element satisfy this condition? All asks, does every single element satisfy it? Both return a bool. Let's write them.
Any pop, all ancient, and any with no predicate. I'm betting that just checks if the lights are on. Is anyone home in this list?
True, true, and true. We have a pop song. All 5 songs are before 1990, and the list has at least one element. Now, notice that last one. Call any with no predicate and empty parentheses. That's the idiomatic way to check if a collection is empty.
Why not just check the count 1, 2, 3? Yup, there are elements. Isn't that what normal people do?
Count has to walk the whole sequence to get a number. Any stops the moment it finds one element. On a large sequence, any can be a significantly faster solution. It also works on a plain IEnumerable, which might not have a count property at all.
Short circuits, it's like finding a sock in a messy drawer. The moment you find one, you stop looking. Efficiency strikes again.
One edge case worth knowing. What does all return when the list is empty?
False, I mean, how can all be true if there is nothing? That's some Inception level logic right there.
True. It returns true. This trips people up. Do all elements satisfy this condition? If there's no elements, there are no counterexamples. So the answer is vicariously true. The practical takeaway: always confirm the list is non-empty with any first. If a empty list true would mislead your logic.
Vacuously true, nothing is wrong because there is nothing. I'll use that on my next performance review.
Before we wrap up, 3 mistakes that catch almost everyone. They all look fine at first glance. None of them cause compiler errors.
Silent but deadly, it's a trap. Lead the way, Admiral Akbar.
First one, iterating a raw IEnumerable twice. Glitch, write a query without ToList, then loop over it 2 separate times.
The lambda is verbose so we can track it. 2 loops, 1 variable. Double the loops, double the fun, or is it?
Look at the output. The lambda messages appear twice, once for the count loop and once for the print loop. The lambda ran 10 times total, not 5. Every iteration re-executes the whole query.
It's Groundhog Day, the query doesn't remember its results. If that were a network call, I'd be racking up a huge bill. ToList is the only way to make it stick.
Exactly. Call ToList once. The query runs once, and both loops read from the materialize list. Second mistake. Calling first when the sequence might be empty. We saw this already when we searched for jazz, but it's easy to do by accident. Write first with a search that fails.
Searching for jazz, again, it's like looking for a sane person on the internet. First is about to have a meltdown.
Invalid operation exception. Right on cue. Sequence contains no matching element. Anytime you're searching for something a user might have provided and no match is possible, first is the wrong choice.
So first is the arrogant detective. It assumes it's right, and if it's not, it quits. FirstOrDefault is the humble intern. It looks, and if it fails, it just shrugs and says null.
Exactly. Last mistake. This one's subtle, confusing where and select.
Confusing the filter with the projector, that's like confusing a coffee filter with a slide projector. One makes your day better, the other just shows you pictures of your vacation.
They look similar. Both take a lambda. The mistake happens when someone wants rock songs and reaches for select instead of where. Try it exactly as a student would write it.
Select with a boolean lambda. I'm expecting a list of songs, but I'm probably going to get a list of true/false stairs.
count 5, then true, true, false, true, true. 5 booleans, not the rock songs. You asked select to transform each song into the result of a comparison. It did exactly that. Every element goes through. Nothing gets filtered.
It's the Truman Show. Everyone is there, but they're all just pretending to be booleans. Select reshaped the world, but it didn't change the population.
Right. The mental model that fixes it. Where asks which ones, select asks what should each one become. If you're trying to answer which ones, use where. Here's what to practice. Start with a list of city names. Write 4 queries. Use where to find all the cities starting with the letter S. Use select to project those into uppercase. Use any to check if the city has more than 8 characters, and use FirstOrDefault to find the first city containing AN. Then print it if it's found, or print none found if not.
Filter, transform, check, find. It's the Goonies checklist for data. I'm on it, dev.
Filter, transform, boolean aggregate, single element lookup. Once those 4 feel natural, the rest of LINQ follows the same pattern. Chain them, filter early, and materialize when you need the results to stay put. Don't just watch it, do it.